Hello, this is Lauren Foley. This is my reassessment for 3.1. I will be doing a question from WebAssign, which states a planet of mass 6 times 10 to the 24 kilogram is at a location 4 times 10 to the 11th, negative 5 times 10 to the 11th, in 0 meters. A star of mass 5 times 10 to the 30th kilograms is at a location negative 5 times 10 to the 11th, 3 times 10 to the 11th, and 0. The diagram showing the star and the planet and the relative position vector pointing from the planet to the star, also the unit vector. And in this problem, we must find the relative position vector, the unit vector, the magnitude of the force exerted on the planet by the star and by the star on the planet, and the force vectors exerted on the planet by the star and the force vector exerted on the star by the planet. Question is, what is the relative position vector pointing from the planet to the star? So we take the two vectors, subtract them, and we get our relative position vector. Step is to find the distance between the planet and the star, and we do this by taking the square root of the relative position vector, and this is what I got. Next step in the problem is to find the unit vector of r hat in the direction of the r vector, and we take the relative position vector and divide it by our distance from the planet and the star, and we get this as our r hat. Next step is to find the magnitude on the force exerted by the star to the star by the planet. And so we use the formula for gravity, mass 1 times mass 2 divided by the distance between the planet and the star squared. And so we take 6.7 times 10 to the negative 11 times 6 times 10 to the 24 times 5 times 10 to the 30th divided by 1.20 times 10 to the 12th squared. This comes to be 1.40 times 10 to the 21 newtons. And this is also the magnitude of the force exerted on the star by the planet. Now we need to find the force vector exerted on the planet by the star, and to find the force vector, we multiply our magnitude of the force exerted on the planet by the star times the unit vector, and we get negative 1.05 times 10 to the 21, 9.24 times 10 to the 20th, and 0 newtons. The last thing we needed to find was the force vector exerted on the star by the planet, and that is just the opposite of the force vector exerted on the planet by the star. So we have 1.05 times 10 to the 21st to the negative 9.24 times 10 to the 20th, 0 newtons. So this is basically the opposite of our other vector because we were going in the other direction. I entered in my calculations to WebAssign, and I got all the right answers. My video on how to find force vectors and everything that comes before that for reassessment 3.1.